Good afternoon, everyone. I hope you guys enjoying this fantastic workshop. Yes, as Mark said, I'm joining you guys from Reno, Nevada. We are the State Geological Survey. We offer the research and public service to Nevada, specifically in the exploration, mineral economy, economic geology, and also geothermal. And today's story, I'm going to talk about the solar energy and Tellurium, more specifically for the cadmium telluride solar technology. And before that, when we're talking about this industry, we're talking about the two different value chains. So one of them is the solar energy value chain, and the other one is the, of course, mining value chain, raw materials or primary value chain. So as the International Energy Agency recently reported, renewables are going to account for 80% of the new power capacity by 2030. And for solar panels, that's going to be almost accounting for more than half of that. So fun fact that I love, we have about over 2 billion years sunshine, so that's going to be more than enough for generation after generation and after generation. And in terms of the solar energy value chain, the next step would be the primary materials that we require for this technology. So that would be tellurium in this case. And this energy transition, apart from tellurium, requires a lot more other metals. Once it comes to the tellurium, a lot of people might wonder why this technology. So a study shows that the payback times and also the environmental footprint for cadmium telluride PV technology is kind of better than the rest of the other technology. So we kind of pushing to have more of this technology around. Right now the First Solar is pretty much the monopoly of this kind of technology, and this technology has been developed, I think, back in 50s. In terms of the efficiency, it's around 28%. So that's the pretty much a standard efficiency for solar PV technologies. But remember, this technology offers the better payback times. It means the module that you use in the energy conversion, those things is better. Also, when it comes to the environmental footprint, like a CO2, cadmium telluride, again, technology is much better than the rest. So right now I'm going to focus on the tellurium again. But when it comes to the mining, we have multiple challenges, or I would call them opportunities. On the right hand, on your left side, you will see a general trend of the ore grades going down. So this is not for only copper, pretty much for all of the precious and base metals. We have this downward trend of the ore grade, and that's the one big issue that we have right now. So we have to kind of move to kind of dig deeper and deeper, and we also have a lower quality of our ore, so it's going to be more expensive. And also, we saw one of the top mining businesses is the ESG, so it means we have to put more energy, put more money, more workforce to get what we used to get before. And on your right end, you see the wheel of metals. So as you see, a lot of these critical byproducts, they're associated with the primary metals, like a copper, gold, and the other base metals. So they are not necessarily reported in the geochemical analyses. Also, the companies, they are not obliged to report those things. So it's not the kind of a standard as we're talking about. So for tellurium, when we are talking about the tellurium supply chain, the majority of that is coming from the anode slime. So anode slime is the kind of leftover from the copper industry. So they kind of collect it, they put it in the box, and then you have a kind of mix of chemical reactions in a blender, and then you have this tellurium at the end. So right now it's about $70 to $100 per kilogram. And so that's going to kind of pose a significant risk for having a sustainable supply chain for tellurium. Apart from the technical issues around the processing, you also have a geopolitical risk coming from China, like the rest of the other critical minerals. So we have to kind of understand how we can kind of improve this secure supply chain for tellurium. And when it comes to the global tellurium flow, so the numbers in the brackets back to 2018, and the one first, like for example, China, when it comes to the refinery of the production, is pretty much 60 to 70% of the current refining data. So this number is published by the USGS. And you see the rest of the countries, they're pretty much contributing kind of low. And when it comes to the consumer market, we see, again, cadmium telluride technology that's pretty much taking up to 60% of the consumer market. And for example, if we look at the tellurium, so right now we have about 1,000 tons per year of available supply. And when we look at the annual report of the First Solar, for example, we see that we have about 40 gigawatts production. So with the assuming around 75 per ton of the for every 1 gigawatt First Solar, for example, using 75 ton, that's going to be roughly around, again, the whole supply chain that we have, so around 1,000. So it means we need to kind of do better in terms of the low-hanging fruit and also unrealized supply chain. So for this presentation, we're going to focus on those low-hanging fruits because I've said we don't know where this tellurium comes from and within the existing base and precious metal supply chain. So that's going to help us to kind of increase the sustainability and ensure secure supplies. So the way that we've done it, we kind of come up with the proxy that's based on the public data, research papers, and also the company report and so on. So we started with the 92 mine sites across the US and Canada because we had only 61 available tellurium proxy grades. We moved to calculate the contained tellurium based on this proxy grade and also the current mineral resource and reserves reported by the companies in 2 different years. And then in terms of the production, we assumed that we will be able to recover 50% of that. So this is the map of this different operation, mostly around the East Coast, and then we have the Bingham in Utah, and then we have some other mines around the Ontario, Quebec, and so on. And the good news is that, Rio Tinto back in 2022, they started to look at the opportunity for tellurium extraction. So this is the nice picture of this fantastic operation. And when we did the calculation, so based on the Rio Tinto data, they produce around roughly 20 tons per year. And the data the value that we have based on this proxy is around 24. So our proxy is kind of like roughly giving idea what are the potential tellurium supply chain within each operation. And that's pretty much summarized the different operation across US and Canada. And we see a lot of them have the potential to move forward with their tellurium processing unit. So some of the takeaway points is we understand that we have a opportunity to kind of recognize the full value of mining and improve the security of the tellurium. And we kind of developed a proxy that showed us where are the low-hanging fruits. And with that, please reach out to us. And if you have any opportunities, if you have any ideas, in terms of the collaboration, either company, government, please reach out to me or Simon. Thank you.